Hi everyone, this is Shankar, Assistant Professor in the Department of Computer Science and Engineering from RMD Engineering College, Chennai. So today lecture series we are going to discuss about type of coding techniques. Under this, today we will cover only Shannon-Fano. Right? There are two types of coding techniques are there. One is Shannon-Fano coding technique, and another one is Huffman coding technique. Let us see what is Shannon-Fano coding. In Shannon-Fano coding, an entropy encoding technique for lossless data compression, it assigns a code to each symbol based on their probabilities of occurrence. It is a variable length coding scheme. The procedure for Shannon-Fano is first, we have to sort the list of symbols in decreasing order of the probability. It is based on probability. We have to sort the symbols in decreasing order. Next, we have to split the list into two parts with the total probability of both the parts being as close to each other as possible. And next, we have to assign the value 0 to the left part and 1 to the right part. So we have to iterate the steps again and again from 2 and 3 for each part until all the symbols are split into individual subgroups. Let us see the example. The example given that the given task is to construct Shannon codes for the given set of symbols using the Shannon-Fano lossless compression technique. The symbols are represented as S equal to S1, S2, S3, S4, S5. Its equivalent probabilities are 0.3, 0.2, 0.2, 0.2, 0.5. So let us see how we are solving this problem with Shannon-Fano. So the first procedure is we have to sort out the symbols in a decreasing order, right? So by luckily, in the given example, it will be in the order of decreasing order, sorted order in the form of decreasing order, right? So S1, S2, S3, S4, and S5. Its probabilities are 0.3, 0.2, 0.2, 0.2, 0.1, right? So we have to sort the order. It is based on the probability. The next step, we have to split the probability in two halves that is closer to the each parts. So 0.3 plus 0.3 is 0.5. The remaining are 0.2, 0.2, 0.1. So both are equal. 0.3, right? Sorry, 0.3 plus 0.2, 0.5, and the down one is also 0.2, 0.5. And next, what we have to do, we have to assign zeros to the left part and ones to the right part of each symbols. And next, we have to again split the first off. That is, first we have to iterate the left part until it getting individual elements, and later we have to switch over to the right part. So in the left part, we have only two symbols, so there is no problem. We have to split it into two halves, and we are assigning the codings called 0 and 1s. And next, we have another right part, and we are also divided into two parts that is closer to each other. So the left part we are assigning 0, and the right part we are assigning 1. So similarly, again we have a right part. So two symbols, right? Because we have to iterate the steps 2 and 3, right? You just recall the procedure what we have discussed until we are getting individual symbols. So in this case, in the left part, right part, again we have two halves. That way, again we are going to split it into two parts. So again we are assigning the left part as 0 and the right part as 1, right? So now we have to take the Shannon-Fano coding, right? So for S1, the code word is 0, 0 because the S1 is 0.3, 0.3. And the next one, 0.2. So 0.2 values are 0, 1. The code words we are taking from left to right. And next 0.2, 0.2 is from here. So 1 and 0, and that is 1, 0 only. Right? And the next S4, the codes are 1, 1, 0. So 1, 1, 0. Right? And next S5, S5 codes are 1, 1, 1. Right? So the code words are, it look like this. So we have got the code, and next we should find the entropy, average number of bits, and n bar redundancy and code variances and so on, right? So this is what about your Shannon-Fano coding. Thank you. Thank you all for watching this lecture series.